So the first 2-3 problems that we're going to be looking at, I'll be honest, I'm going to have some communication issues, not because it's necessarily super-duper hard, but if I ask you to do what I do, it's pretty easy to follow along. I'm going to show you a process and you're going to mimic the process. If I tell you to see what I see, that's a little bit harder. That's like trying to explain to somebody what the color purple looks like. It's really hard to do. I'm going to do my best, but I'm going to need lots of questions from you guys. If you're not understanding something, please ask me a gazillion questions because I want to make sure that I'm communicating as clearly as possible so that you can learn to see what I'm seeing. Okay? So on this graph to begin with, we want to identify the domain. What is the domain? Like, what do I mean when I say domain for any problem? X's. All the things I'm allowed to use for X's. So I'm looking left and right on my graph. I always start off on the far left side, and then I move my way over to the right side. I did not see a hat in here. Sorry, dear. So I'm going to start as far to the left as I possibly can. And I'm looking for the X values, because we're talking about domain, right? All right, so if I start all the way over here on the left, what's the farthest to the left that my graph starts? -3. So I would start my domain with -3. There's a dot right there, isn't there? Is it filled in or is it open? Filled in. So I'm going to write this using interval notation. If it's a filled in dot, do I use a square bracket or do I use a parenthesis to show that? Square bracket if it's filled in. That's okay. The parenthesis, let me see if I can explain this in a way that, the way I think about it. I don't know about you guys. I grew up with a younger brother, but we're pretty close in age. And we would take road trips together as kids, and he and I always got stuck in the back seat. And like kids will do, we would fight and argue about stuff. Specifically, he's touching me, she's touching me. When I use a square bracket, it's okay to touch that value. When I use a parenthesis, it's not okay to actually touch that value. Now, I was a real pain growing up, and I would antagonize my brother.
I'm not sure I understand.
That's nice. And so I'd be sitting in the back seat, and I'd have my finger about here. Mom, she's touching me. No, I'm not. She's touching me. No, I'm not. No, I'm not. I'd get really, really, really close, and I'm still following all the rules. I'm not touching him. I'm not touching him. That parenthesis means I can get really, 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 really close as long as I don't actually touch it. Does that make sense? Or at least a little bit more sense? Okay. Hopefully it'll make you smile when you think about it too. So we're going to start at -3. I'm allowed to touch that value. That's what that filled in dot means. I'm tracing along this graph. Do I have to pick up my pen at all as I'm tracing? No. I can keep tracing until I get all the way to where? Remember, I'm looking at which values for domain? At the x's. So I can go all the way to where on the x-axis? All the way to 4. Am I allowed to touch the 4? Yes. How do I know from looking at the graph that I'm allowed to touch it? It's a filled in dot. So there's my domain. Range. For the range, I'm not looking at the x's anymore. Now I'm looking at the y's. So am I still going left and right? Now I'm going which way? Up and down. With domain, I always start as far as I can on the left, and I move as far as I can to the right. With range, I start as low down as I can, and then I see how high can I go after that. So what's the lowest this graph ever goes? Negative, am I looking at the x's or the y's? -2, because I'm looking at the y's for my range. Am I allowed to touch it? Yes. So bracket or parenthesis? Bracket. -2, and then I'm going to go, we're going higher and higher and higher. Is this the highest the graph ever goes? No. I go down a little bit, but then I come up again. What's the highest I ever get? 2. Bracket or parenthesis? Bracket. Are we somewhat comfortable with that? Okay. Part C. F of 1. If I gave you a function rule, pretend for just a minute that I said f of x is 3x minus 5. What would you do if you saw something that looked like this? Substitute the 1 in for x. That's exactly what we're going to do, except I'm going to do it on the graph. So this is going to be my input, my x value, and I want to figure out what the output or the y value is. So I'm going to go to the graph. I'm going to go to which value on the x-axis? I'm going to go to 1 on the x-axis. That's right here, right? Here's my input. What's my output at that point? 0. Here's the output. So that's what I would write right here. Do you guys understand what I was looking for, what I was seeing there? Okay. For part D, I want all x such that f of x is equal to 1. Is this 1 right here input x values, or is it output y values? Output. So I'm looking for everywhere that 1 is the output, is the y value. So looking on my graph, I'm going to go to 1 on the y-axis. That's right here. And I want to look anywhere along that x-axis where I'm at that height. Do you guys see anywhere where I'm at that height? -1. Anywhere else? 1/2. Anywhere else? 2. It crosses there in 3 places, so those 3 inputs give me the output that I'm looking for there. I'm going to write this. I'm going to circle it with this color. I'm going to write this inside curly brackets, not interval notation. When I use curly brackets, that means it is just single values, not whole ranges. Okay, I'm using curly brackets because when I use my interval notation, that means I can go all the way from here and I can go through every number in between until I get to here. Here, I only have 1, 2, 3 exact values. If I substitute things in between those numbers, it doesn't give me an output of 1, does it? No, just those 3 numbers do. So if I use -1 as my input, it spits back a +1 as the output. That's what that point means there. If I use a 1/2 as my input, what does it spit back as the output? +1.
Doesn't it have to be greater than 1?
I'm doing part D right here. I'm doing the one that says equal to 1.
Oh, wait, I didn't see the part C.
That's okay, yeah. I know, part C is like off to the side there.
Okay. I thought we were doing, like the last person, I thought we were doing D this entire time.
Got it, yeah. We'll talk about part D in a minute. Is there any other x value that when I substitute it in, it spits back a 1? 2. Are there any more? I don't use my interval notation because I can't choose things in between these numbers. If I put a positive 1 into this function, that doesn't have an output of 1, does it? When it is single values, not everything in between, we use the curly brackets. All right, now we'll get to that guy on the bottom here. Part E. Part E is really similar to Part D, but with one slight difference. What is that difference? Greater than. So now I want my output, my y value, to be exactly 1. Is that what it's saying here? No, I want my y values to be bigger than 1. So where would I look on this graph to find things that are bigger than 1? What'd you say?
Above 1.
I'm going to look above that line that I just drew for the last one, right? Can I include things that are on that line? Why not? It's not bigger than 1, it's exactly 1. So I'm looking up here. Let me get my highlighter going. Thank you. Do you need a pass? Yeah. Give me just one moment. I'm looking up here. All right. So I'm looking at my graph. I'm only looking above that red line. And what I'm seeing is that right here I'm above that line, right? That's part of my graph. And my output is greater than 1. Anywhere else I'm above that line? Yeah, 4, 2, it goes up there, and everything that comes before that, right? So over here, my output is bigger than 1. You said I'm not including the dots that are actually on the line because it's equal to 1 there, right? So I want to describe where my pen starts along the x-axis and where my pen stops along the x-axis because I want all the x's that would give me output values bigger than 1. So if I start my pen right here, where am I on the x-axis? -1. Am I allowed to touch -1? No. There is a dot there, but why can't I include -1 this time?
Because it's close there.
Yeah.
Less than.
I want things that are greater than 1, and right there it's exactly 1. So I need a parenthesis here. All the way up here I'm bigger than 1, right? Until I get to right here. Where am I on the x-axis there?
2, 3, 4.
That's 4 on the x-axis?
1/2.
1/2 on the x-axis. Can I touch that one? No, because it's still not bigger than 1 there. And then in between here and here, what happens to my function?
It dips below the line.
It dips below.
Asymptote.
Sort of. You can treat it like an asymptote, yeah. You can think of it that way. So there's this space where I'm not bigger than 1 at all, right? How am I going to explain that there's this gap? Union. And then over here it pops back up above that line, right? Where am I on the x-axis when it pops above that line? At 2. Bracket or parenthesis? How do I decide?
It's because it's not on 2, because that would be on the low line. We need it greater than.
Need it greater than. So it's got to be a parenthesis. I can't touch it. But 2.000000001 would be just a little bit bigger. Not touching 2, but just a little bit bigger, which means my output would be just a little bit higher. All the way until I get to where? 4. Can I touch that one?
Yeah.
Why? Yeah, it ends, but it's above that line. My output is bigger than 1 over there. So that is allowed. You guys okay with how I came up with all of these? I've got some yeses and some nos. I don't want to move on until I'm getting all yeses. Which piece are you confused on, dear? Because if you're lost or confused, I want to make sure to clarify. Like I said, what I'm doing today is kind of like explaining out loud in words what the color purple looks like. I can try to describe it. I can tell you other things that are that color. I can tell you what I'm seeing. But whether or not I'm doing an effective job communicating, I'm going to need some feedback so that I know whether or not you're getting it. So you were telling me no. What is it that you didn't understand? Or which piece? A, B, C, D?
Explain E.
How do I explain E?
Yeah.
Okay. So this is telling me I want the x's, that if I substitute them into this function, the output, the y value, is bigger than 1. Here's a line that's going through 1 on the y-axis. So far, so good? All the things that are underneath that are less than 1. I only want things that are bigger than 1. Does that make sense so far? Anything that touches this line on my graph, so anywhere it intersects this line, that's where it's equal to 1. I don't want it to be equal to 1. I want it to be bigger than 1. So I have to be above the line. Does that part make sense? Okay. So I see 2 places on the graph where it's doing that. I see it right here, and then I also see it right here. Do you see those 2 spots? Because it's 2 separate spots, I have 2 intervals with a union in between them. Does that make sense? Okay. Does anybody else have any other questions about this? Let's look at another one and see what we can do with another one. Okay? This graph, you might want to snap a picture of. On this one, just like the last one, there are 5 things that I want to identify.
Wait. I'm taking a picture of it. Wait, what?
I'm suggesting snapping a picture so that later when you're looking at your notes, if you didn't draw this in your notes, you know what, you can go back and look at this picture.
Why don't we draw it?
You can draw it if you want to. It's just going to take you some time, and I'm getting ready to write down the domain, and we're going to keep scooting forward.
Oh, okay.
All right, so my domain. All the values that I'm allowed to use for x. We always start with the smallest, so I always start the farthest to the left. Where does this graph start if I'm all the way on the left-hand side of the picture? -5. Right here is my first point, and I want where I am on the x-axis. So -5. Am I allowed to touch it? So is that a bracket or a parenthesis? Bracket. So I start here. I trace all along. Am I having to pick up my pencil at all? So all these x values in between are valid. All the way until I get to here. Where am I now? -3. If I go straight up and down from here, does the graph pick up anywhere else at -3? No. So there's a stop there. I'm going to have to close this interval. If I could go down here and the graph picked up again, then I wouldn't need a break. I wouldn't need to end my interval. because the function would keep going just in a different spot. Where am I on the x-axis when it does that? You said -3. Am I allowed to touch this one? No. Bracket or parenthesis? Parenthesis. And then a union, because we're going to jump. If I'm looking at my x values, where's the next place that you see part of this graph show up? -1. Am I allowed to touch it? No. Open circle means I'm not allowed to touch it. And it goes all the way until where? 1. Because if I look right here, that graph doesn't have anything else that's here. It doesn't pick up again until I get over here. So here's where I'm at. Bracket or parenthesis? Bracket. And then there's a gap on my graph again, right? How do I explain that there's a gap? With a union, yes. Where do I put my pencil down again at? At 2. Bracket or parenthesis? Parenthesis. And I can keep going until where? Until 4. Bracket or parenthesis? Bracket. That domain was a pain in the rear. There were 3 separate spots, and there's no graph in between -3 and -1. There's no graph in between 1 and 2. There's these empty spots. All right, let's do our domain, or sorry, we just did domain. Let's do range. So now I'm going bottom to top. What is the lowest my graph ever goes? -3. When I'm down here at -3, does it go up from there? No, not without picking my pencil up, right? And there's a gap between here and the next place I see the graph show up. So I need to have -3 on here. But you said I don't move at all. It just stays right here, right? It's just a single number. Not a range, but a single number. So I'm putting it inside curly brackets. Because the range, the y value, doesn't change anywhere along here. It's -3 over here. It's still -3 over here. It doesn't go up or down at all. So far, so good on that one? What's the next lowest this graph ever goes? -1. I have to come all the way up here before I touch the graph again. Would that be a bracket or a parenthesis there? A bracket. So -1. Because I can move along here without picking up my pencil, I know all the values in between -1 and 0 I have outputs for, right? In fact, I can go all the way up to here. I can go all the way up to what on the y-axis? 3. Does it keep going higher than 3 over here? What's the highest I ever go? 4. With a bracket, because I'm allowed to touch it. There are output values for everything in between -1 and +4. If I go back and forth across the graph like this, I can run into the graph until I get up here. Here I cross, here I cross. If I'm able to cross my graph, then I have output values. Do you guys see what I'm seeing? Okay. Increasing.
Wait a minute.
Yep.
The -3 with the squiggly thing in there. Why is it just negative? Wait, because it's just, I don't know.
What do you notice about the output, about the y's all along here?
The output, you're both -3.
They're both -3. Is there any wiggles in between that go higher or lower than that?
No.
No, it stays constant. So it's just one output there. So I only wrote one number right there.
It's not nothing to do with the inputs.
Correct. Has nothing to do with my inputs. It has to do with the output all along that way. Doesn't go up, doesn't go down.
Gotcha.
All right. Increasing.
Another question.
Yep.
About the range, why don't we just do like -1 and then 3 and then 0 and 4? Like, because it's two different parabolas.
It is. But this is all one function. This is all one function. I don't happen to know what the function rule is for it, but I have the graph for it.
And if it's all one function, why do we put the -3 separate?
So my range has to tell me all the possible y values that I would get. So it's possible that I get -3 as a y value, right? Because I see those points plotted down here. Is there anywhere on this graph that I would get an output, a y value of -2?
No.
No. There's no outputs down here at -2. Is there any way I'd get an output of -2.5?
No.
No. This output down at -3, it's just at -3.
Wait, so the U, or the union sign, is because of the gap
Yes.
between, okay. I got
Yes.
you. I
When
got
I'm
you.
looking from the bottom to the top, it's because there's a gap. There's output down here, but then my output doesn't start again until higher than that.
I got you.
Yes. Awesome. Increasing. What does increasing mean? That it's going up. What does decreasing mean? That it's going down. If I'm talking about things going up or going down or staying constant, what does constant mean? Not changing. I like what Miles did with his hand there. Increasing means going up. If I'm going up, is that an output or an input thing?
Input. Output.
If I'm thinking about high and low, are we looking at domain or range?
Range.
Range. So increasing means my y's are getting bigger. Decreasing means my y's are getting smaller, right? Constant would mean what? My y's aren't changing. When I write the intervals for increasing, decreasing, and constant, I'm going to look for the inputs, the x's, where the outputs are doing that. So for increasing, I'm looking at where would I put my pencil that if I traced this graph, my pencil is going up. So as I start over here on the left, if I put my pencil down where the graph starts, over here at -5, is my pencil going up or down here? Down. At -5, all the way until where I'm going down? -4. So I should put that for which piece here? Decreasing. From -5 to -4, we're decreasing. Should I use brackets or parentheses? Brackets. I get down here to -4, and now my pencil is doing what? Now it's going up. Yes, Carrington? We're going to take the x values and write those down as our intervals. Yep. And it's describing what the y's are doing as I move along that space. So from -4 until where my pencil is going up? Until -3. Do I want a bracket or a parenthesis with the -4? Bracket. What about at the -3? Parenthesis. All right, I get over to here, and then I have to pick my pencil up, right? The next spot I can put my pencil down is where? -1. And what's the graph doing here? Constant. From -1 all the way to +1. My graph is constant. Brackets or parentheses or one of each. Parenthesis first, because I have an open dot at -1. Bracket around the +1, because because I have a filled in dot here. Is there anywhere else on the graph where my output is constant? Then that's my only interval for constant. So I'm over here at positive 1 on the x-axis. Where do I go from here? To 2. So I start my pencil at 2, and I'm going to trace along this graph. What's my pencil doing? Going down. Was there a gap
Yeah.
between where I was going down before and where I'm going down now?
Yeah.
Yes, so I need a union. You said I'm at 2. I'm going down from 2 until where? 3. Brackets or parentheses? Around both of them? Parenthesis around the 2 because it's an open circle at the 2. What about at the 3? Bracket. Is there anywhere else on this graph that I'm going to be going down? No, then I'm done with decreasing. From right here at 3 until I hit the edge of the graph, what's my pencil doing? Going up, increasing. Starting at 3 on the x-axis and ending at 4. We are increasing. So union from 3 to 4, brackets or parentheses. On both of them?
Yes.
Am I allowed to touch them? Yes, I am. How we doing?
So when would we not have a union sign? Like, what, like?
Let me show you an example of when we would not need a union sign. What's this graph doing the whole way if you start on the left and move to the right? Decreasing. Is there anywhere that it's increasing? No. Nowhere is it increasing. Is it ever constant? No. So I would say that this one is decreasing from negative infinity to positive infinity. And for the other two, increasing, I would say none. Constant, I would say none. Here's another example of when you would not need a union. Am I ever going down here?
Yes.
Yep, when I go from left to right, if I start on the left, I'm going down, right? Until I get to right here. So from negative infinity until 0, I'm going down. And then I turn and do what? And then I go up. And I never turn and go down again. If I ever have the same behavior more than once on my graph, then I'm going to need a union. If that behavior only happens one time, then I don't need a union. All right, we're going to practice sketching something here. We're going to see how we've done with this increasing, decreasing thing. I want to sketch a function that is decreasing on these intervals. So it's going down, but it is increasing on these intervals. First thing I do on this is I look at those intervals. Do you guys remember when we were doing the number line and we found our zeros and we said, is it positive or negative on the last test? How we took our number line and chopped it up into pieces based on where the zeros were? I'm going to take my graph and I'm going to chop it into pieces based on my intervals. So read to me all the numbers that are parts of my intervals. Negative infinity, but I can't see that on my graph, right? Negative 2. So negative 2. I'm going to chop my graph up right there. Positive 1. I'm going to chop my graph up there as well. Tell me any other numbers that are parts of intervals. 4. Are there any other numbers? Not that we can graph, you're right. All the way on the left over here. Which interval is that? Negative infinity to negative 2. And what do I want the graph to be doing over here? Decreasing. This interval right here, in between negative 2 and positive 1, what do I want the graph to do there? I want it to increase. What about in between 1 and 4? I want it to decrease. And what do I want it to do all the way over here? Increase. Your graph is probably going to look wildly different than mine, and that is perfectly okay. Yours doesn't need to look anything like mine, as long as it's decreasing on the left and then increasing in that next little space, and then it goes down and then it goes up again. So I'm going to start all the way on the left, and I know my pencil needs to be going which way? Down. So I'm going to make it go down until I hit right here. Because when I hit that first up and down line, what does my pencil change to do? Now it's going to go up until I hit this line. And then my pencil goes down again until I hit that line, and then it turns and goes up. Yours might change a whole lot more than mine did. Yours might come way down and way up, and then way down and way up again. Yours might come down just a little bit, and then go up just a little bit, and then down a little bit, and then up again. As long as when you put your pencil down on the left side, it goes down until you hit the first dividing line. And then it goes up. And then it goes down, and then it ends going up. It doesn't matter where your graph is on the page, but it should have kind of a W shape to it. It might be a big W. It might be a little W. It might be a cockeyed W. But it should have a basic shape of a W because it starts high and it goes down, and then it goes up and down, and then it ends by going up. All right, there's one more thing that I want to look at with you guys before the end of the day today. It's how to look at a function rule and determine what the domain is just from the rule.
Wait.
Yep.
How is negative infinity the x value, and then negative 2 the y value?
Negative 2 is not the y value. Negative 2 is still an x value.
Oh, are they both x values?
Yep. Everything, whenever they give me those intervals here, because they talk about increasing and decreasing. Increasing and decreasing is what the y's are doing. So the intervals that they're giving me is where I'm at on the x-axis. So negative infinity to negative 2 tells me that I'm looking over here on the x-axis.
Ah, okay. Oh, I got you.
From 1 to 4 tells me that I'm here on the x-axis.
Okay.
Does that help?
Yes.
Okay. All right. Last couple minutes. Find the domain for each. What kind of function is this? Square root. Underneath the radical, I can never have what kind of number? Negative. No negative numbers. Is it allowed to be 0? Can you take the square root of 0? Yes. Yep. So as long as 4x minus 1 is some number greater than or equal to 0, I'm okay, right? So what do I do now to isolate x? Add 1. And then what? Divide by 4. So all of my x's have to be bigger than what? 1/4. Bracket or parenthesis? Why? or equal to. Can I use any kind of big number I want to? If x was 100, is that okay?
Yeah.
If x is 1,000, is that okay? So this can go on to infinity, and that's perfectly fine. But it can't be any smaller than 1/4, because then I would get a negative under my radical. What about number 2? Are there any values that x is not allowed to be? What is my denominator not allowed to be? Denominator is not allowed to be 0. So that means x, Miles, you said x can't be what?
1 or -1.
Can't be 1, can't be -1. So here's how I write that domain. If x was -100, is that okay? So I can have any kind of negative number I want to all the way until I get up to -1. Am I allowed to touch -1? So how would I explain that? Parenthesis. Then I'm going to have a union because I'm not allowed to touch -1. Am I allowed to choose numbers in between -1 and +1? Like if I had x as 0, is that okay? Yeah. It's just -1 that I'm not allowed to touch. So here's how I just leave out that one number. I can go all the way from like -0.9999999 all the way up until I get to what? 1. Am I allowed to touch 1? Nope. So another parenthesis. Am I allowed to go with 1.000001? Yes. So I'm not allowed to touch the 1, but I can choose something barely bigger than that. Can x be something like 100? So this can go on to infinity. We'll do a couple more of these on Monday, and then there's 2 more types of examples I want to look at with you. That will finish up 3-4, and then we're going to start 3-5 on Monday also. All right? Your homework over 3-4 is going to be due on Monday night. You can do almost everything in that homework. You should get started on it over the weekend. If there's anything that you don't know how to do, save it for Monday and ask me questions then. Okay? I hope you guys have a fantastic weekend.